Hello and welcome to this Friday where we are starting our live sessions with a discussion on fractions. Now, I did remind you to have a look at the schedule and see what is on the menu, especially this week with midweek holiday and some self-paced sessions. I hope that you did do the first part of fractions. That mainly just introduces how we are interested in looking at fractions. It's not about the calculation as much as it is about, sorry, I'm just multitasking here, as much as it is about focusing on that very first introduction to fractions. All right, please remember to mute your mic, otherwise I'm going to mute it, and I might forget that I did that, and then you can't ask any questions anymore. And I don't want that to happen. I want you to ask your questions. Let me just get my setup ready here. My cable is in a weird position. Come on. Nope, that's not it. Hold on. Technical difficulties is always a lot of fun. My tablet is on the wrong screen. Okay, that should be better now. Okay. So we're looking at fractions. I have a different setup today, so I'm trying to get used to it. So remember that we are, everything is sideways. That's fun. That we are working on the left here, where our understanding is as basic as it can be with the topic. I like to use the word intuitive, but I mean, it depends on the topic. If you move chips around to do integer calculations, that's pretty intuitive. It's pretty basic. It's an introduction for sure. And that's where we want to be with our fraction discussion as well. Knowing that, or understanding that, we do have more experience with fractions. Well, most of us. And we can do things in a more efficient way. Certainly, when numbers get bigger, things get a little more complicated, you would naturally or sort of be forced to drift towards using certain properties, being more efficient in those calculations that require it. But the very first step should never have those things. So think about when we do basic integer calculations, we can use the number line model or the chip model. There are no other shortcuts there. But the numbers are so small that we don't need them. It's the very first step. So we're going to do the same thing here. And we're going to focus mainly on the arithmetic. And in this case, we're going to do all of them. We're going to do addition, subtraction today, hopefully. And then next time we have multiplication and division. And we're doing them in increasing order. So they do get a little bit more complicated as we go, but the first two is still a part of our introduction and shouldn't be overly complicated. I just want to get used to how we are going to, what we're going to focus on, how we're going to do it. So let's take an example. let's maybe say, actually, I'm just going to do it by way of the book exercises. I think we're over here. I need to drag it over to show you. Let's zoom in a little bit. There we go. So, as I've said in the previous video, though you can use other shapes like circles and talk about pizza wedges and things like that, pizza slices, wedges on a circle, to me it's a little bit tricky to draw accurately and consistently, so I prefer a rectangle. So the question will maybe say use a rectangle diagram, but feel free to use another shape if you prefer. Just use a diagram, use some geometric shape to explain on the very basic level how fraction addition is done. So this is now like the number line model or the chip model. We're using the specific method to explain how to get the answer of those two fractions added together. So we have 2/3 and 1/5. Okay, let's do it. So 2/3 plus 1/5. Now it's not the number line of the chip model, but it's sort of at the same level. That's the key, the level. Okay, so I am going to take a similar approach. The first number is how much I have, and I want to illustrate that with my rectangular pizza. Then I just choose out of habit to slice this up vertically according to the denominator, which is 3. And then we have 2 of the 3 slices. Let's color that pink to represent what we have. Okay. Now I'm looking to add. So I want to put that together with, actually I could have done it over here. Let's do it like that. We have space over here. We have the space, why not? So together with another slice of bread or pizza or whatever. So let me slice that according to the denominator for that fraction, which is 5. They're not equal slices, but as long as you get close, right? Try and get as close as you can to make them the equal size, but clearly it's not going to be perfect. It's okay, especially with the 5. So let's color that maybe blue. I only have 1 slice. Oh, not a lot. Yeah, you know, I only saw your question now, sorry. Whether you were taught like this or not is, at the risk of sounding cold, irrelevant. I wasn't taught like this either. And what most teachers do, because fractions with word problems is one of the topics that people are most fearful in teaching, they try and get through it as fast as possible. So they go to the shortcuts, just write a common denominator and get the answer. Don't think about it, just get the answer. Because as soon as you think about it, little Timmy, you're going to ask me questions, and those are going to be questions that I'm not ready for, and I'm anxious about that. So let's just get through this as quickly as possible. That is obviously not what we want to do. We want to build a number sense with fractions as well, just like we did for integers. You take the time, you move your base blocks around, you move chips around, you walk along the number line. You give so much time there, but you're not fearful of that. It's pretty simple. So if Timmy asks a question, there's not much he can ask that's going to catch you, or that you're not going to know how to respond with confidence. Yet with fractions, there's a lot more happening here. And that makes it to me even more important that I want to build a number sense, visualize these things when they're small, get a sense for the size of different fractions. Visualization is such an important thing. And then, yes, when they get more complicated, just like with the integers, when they get bigger, I'm going to have to use properties, shortcuts, two negatives make a positive. In case of fractions, common denominator. But with this, I can explain why that common denominator method and shortcut will work. It's not my starting point. It's when I have to move a little bit to the right. I always start on the left, but as a teacher, I have to be comfortable starting on the left and handling all the questions. And you'll see with multiplication and division, it gets a little tricky to stay on this left, but it's still a very good thing to do. I can easily go on a rant for 30 minutes, so let me try and contain myself here. So I know how I need to combine these two quantities. I see the two quantities, but they are not quite comparable because their denominators aren't the same. To compare fractions, we have to make them comparable by making them equivalent to the same amount, but with a different denominator. So what we're going to do is, for the pink one, take the other denominator and split and cut that bread, let's call it bread, cut that bread horizontally into 5 slices, like this maybe. Not blue, no. That'll just be confusing. Now I'm trying to make these as even or equal as possible. Pretending that they're equal, right? It's never going to be perfect. And for my second amount, I'm going to use the first denominator to split that horizontally. So that'll be into 3 slices. So yeah, and while I'm thinking of this, because you are not perhaps familiar with this and it takes some time, absolutely ask questions. Let me know if you have any issues, like what did you do there? How does this work again? Could you repeat this? Well, we're going to do a good number of these. And next week we can have a review as well. So on this first amount, I see now I've broken it up into smaller pieces, but now these pieces are comparable in that perhaps they don't look like it, and we can look at some variations as we go to the next example. A piece like this and a piece like this, they have the same size. Why? Because my standard rectangle is split into 15 pieces and they're all the same, and this is 15 pieces all the same. So those two cover the same amount of bread, if you will. So in the left I have 1, 2, 3, 4, 5. I have 10 of these pink pieces. Now I don't want to rush through this just to get through a lot of examples. We'll have time next week. I'm going to go at a pace that feels good. And of course, I have to put that together with only 3 of the blue ones, right? Only 3, not a lot. Now, a question might be, for little Timmy, these don't look the same, yet you just put them together. The whole issue was that I can't put things together if they're not comparable. Yes, so let's see in the next example if he doesn't like the fact that I split a standard rectangle into the same number of pieces, therefore an individual piece has to be the same. If he doesn't like that, we can modify this, and we'll do that in the next example. So I have 10 and 3. So let's say our result, or that's the results in 13 pieces. So in our first attempt, which there's nothing wrong with, it might raise a question, well, these pieces don't look the same immediately. Okay, so let's keep that in mind. So now I have a sentence. What I've done here, and you'll see this theme carry through to the other operations as well. What we do essentially is take a fraction calculation and translate that to an integer calculation. I took these fractions and I transferred them to 10 plus 3, which I'm much more comfortable with, of course, and I got 13. Now I have to go back to a fraction answer. So I have 13 pieces, and that's, in terms of a fraction, going to be relative to a standard rectangle. So for a standard rectangle, I can look at any one of them, just don't look at the color. And I can say it takes 15 pieces, whether they are more square-like or more flat. It takes 15 to fill or make one whole rectangle or pizza or whatever you want to call it. I now have 13 out of the 15. So we end with 13 fifteenths. You can stop there, but remember, attached to a fraction, it's always of a whole. Rectangle in this case. We don't always say it because it's always there, with some exceptions later. Standard sentence. It's always in reference to something else. Whether we say it or not, a fraction does not stand alone, ever. It's always attached to something. I have 13 fifteenths. Okay, of what? Of a pizza? Of a loaf of bread? Of some standard unit. Okay, so we want to have words, write out sentences, but you have flexibility in terms of how you want to arrange these, which sentences you like to make it as clear as possible for you. Definitely diagrams, definitely some sentences, but you have some flexibility. So let's see how we can alleviate that potential question that little Timmy might have because the pieces don't look the same. And we can do that with our next example. 1/4, 5/6, 1. Oh, no, we already have the number, right? That's number 2. 1/4, still adding, just different fractions. So let's practice this. So I have, and addition is first because it is the easiest one, right? Just like merging some chips, it's the easiest integer calculation as well. So let me have my my first loaf of bread or whatever, and I'm going to split it into 4 vertical slices. I'll fix that line in a second. My lines don't always extend. There we go. And I want to indicate with color how much I actually have of that bread. I only have 1 of the 4 slices. That's okay. I want to put that together with, because I'm adding, another portion of another loaf of bread. Let's split that into 6, but now looking at the previous one, I realize that I am potentially going to confuse little Timmy if I go vertically with the other denominator. Then when I go horizontally with different denominators, the little pieces, though they are equivalent, they won't look the same immediately. So what I could do is go horizontally in this one in 6 slices. So halfway, and then split each half into 3. Knowing that, well, I'm going to do that with the other one. So let's have the number of lines in both directions the same. it doesn't actually matter how I cut the bread, right? It's a little unconventional to cut the bread along its length, but I can do it. And I have a lot of these. I have 5 of these slices. Very nice. Like so. Now, they are obviously not comparable, so I'm going to take the first and split it according to the other denominator in the manner that I haven't done yet. So it'll be horizontal lines. And it'll have to be 6. No, not a little line like that. Come on. Try to make them as equal as I can here, but it's gonna fail sometimes. But it's pretty close. And then for the second amount, I'm going to split it into 4 slices. Of course, the opposite way of what I have so far, so vertically. And I can totally explain why I'm doing that. It's to avoid the visual confusion that they might not look the same, right? They definitely are in both cases, so you don't have to do it this way. Okay, so now let's convert, not pink. Let's convert this to an integer calculation. How many do I have here? I have 6. I have 6 pink pieces. Together with a lot. I have in a row 1, 2, 3, 4. I have 1, 2, 3, 4, 5 rows. Now, it depends on the audience. That I can say 20, or for grade 1 Timmy, no, not, I won't do fractions for grade 1, but for a younger Timmy, count them one by one, whatever gives him confidence. But you can do a quick multiplication to save some time if you want to. Know your audience, know your audience. Okay. So I have 6 of one, 20 of the other one. So obviously together it is 26 pieces. Blue, pink. Now they're merged. Now I just need to put that in context compared to a standard whole rectangle. So the sentence that you'll always see us writing is this guy. It takes a certain number of pieces to fill or make one whole rectangle. That's always going to be a sentence I want to write. The numbers might change, but the sentence will always be the same. It takes, in this case, 24 pieces to fill a whole rectangle. You can count them. You can just say, oh, it's 4 times 6 every time, right? 3 times 5, because I split it into 3 one way and 5 the other. Split it into 4 one way, 6 the other. It's always going to be the product of the two. But I'm not looking for shortcuts in this stage. As annoying as it might be for you, Timmy might need you to count them one by one, to draw another rectangle where I don't see any color. All those things you might need to do. Regardless, you get to 24. So that'll be my new denominator. And I have 26. So we can make one whole with 2 pieces left over. And therefore, we have 1 and 2 24ths of a whole. Simplification is not a part of this. It's a different question, though you could argue it is on the left. I argue simplification is a little bit further in. Common factors and canceling and all kinds of stuff. That's a little further in. That's a shortcut. So, though people are obsessed with simplification, I personally, I don't want to see simplification here. Yes, you might know that's 1 over 12, but that's not the goal here. What is wrong with 2 over 24? There is nothing wrong with it. But we're so conditioned to simplify everything we see. It's silly. It's busy work. It is not necessary to simplify anything. You might simplify stuff that you need in a future calculation. Sure. But that's the end. This is my answer. There's no need to simplify this. And that's not a part of this basic method. Simplifying moves me to the right. Even a little bit. I want to be on this left and build a number sense for fractions. Simplification is going to require a shortcut, canceling the 2's and stuff. Those are shortcuts. Those are properties of fractions. And that's not on my intuitive left side. So I ask every time, don't simplify it. But if you really have a compelling urge, you have to write the answer is 1 and 2 over 24 because that comes from my quantities, my sentences, and everything. If you then feel I need to simplify, must simplify, then after that, fine, I'll look the other way. But that's not technically a part of this question. All right. We take as long as we take. We might not get through fractions. Subtraction of fractions, but let's at least see one of the other ones. We had nice small fractions. Let's at least see one of the other two. I don't think we need to do all of them when it comes to addition, but let me know if I'm wrong. What we want to do is a mixed number. Let's do number 3. It really doesn't matter what's mixed and what's not, right? There's something with whole portions as well. I don't know if I have enough space. I'm not going to risk it. Okay, what was that guy? 2 1/4, 2/3. 2 1/4 plus 2/3. And if you do the other one, try it by yourself. Send it to me if you're not sure. But I think with 3 examples, we should be okay. Everything is the same. I just have a bigger diagram. So my layout might be a little different. I have 2 whole pieces of bread, whole loaves of bread, and then a little portion of another one. So because the first 2 are whole, I don't need to split them up necessarily. And at this stage, I certainly don't have a need to create more lines than I need to. But the last one I definitely do. So let's do that, and I just start with vertical out of habit. But it really doesn't matter. You could have started with horizontal. Doesn't matter at all. Regardless, I have 1 of those slices. Okay, that's what I have. Now I don't have any space, so I'm going to have to, whoops, not in pink. I'm going to have to put my extra, my second amount at the bottom here. That's okay. It's not a big deal. I don't have a lot of those. I just need 1 rectangle, and I do need to split it up. Now, you decide if you like splitting them up in a consistent way, always vertical first, and then running the risk of just having the pieces not look perfectly the same, or avoiding that and having them look perfect from the start. Maybe the second one. If you can avoid questions that aren't needed, it might be better. So for thirds, I'm going to go horizontally from the start. No. so that visually my pieces will look the same and everything is just nice. And I have 2 of them. Okay, that's okay. It's not a lot, but it's not nothing. Okay. Now my goal here is exactly the same. However, because I am adding 2 whole loaves of bread, I'm never going to need to cut these loaves of bread. They're going to stay whole. I could create another whole loaf of bread if I have enough that I'm putting together, but the existing holes won't change. So I can keep those. I never have to cut into them or anything. So let me just change to black here. For the portions that aren't complete whole loaves of bread, I do, however, need to split them up and compare the pieces. So I'm going to split the last pink one up according to the other denominator, which is 3 pieces, or slices rather. And the blue one I'll split according to for the other denominator. So yes, it's time consuming, but I enjoy the drawing and everything. It's nice. I can use my space over here maybe just to have everything on one screen. I have 2 whole, I'll just say holes, rectangles. I mean, that's better. 2 whole rectangles and 3 little pieces that are pink. And I want to put together with that 1, 2, 3, 4, 5, 6, 7, 8. 8 of the same pieces. They are just blue. But when I put them together, I don't care about color anymore. So oops, not blue. All together, we get 2 whole rectangles, or pizzas, or loaves of bread, and 11 pieces. Now they're merged, so they're not pink, they're not blue, they're just pieces. Now I need to put this 11 specifically into context. How much of a loaf of bread is that? Standard sentence again. It takes, I can look at any standard rectangle that is split up to 2 ways. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. It takes 12 pieces to make another whole rectangle. And we have 11. So we have 2 and 11 12s. You don't have to write of a whole, but know that it's always there. So the fact that I have some mixed numbers to start with doesn't really matter. They are not going to ever change. They're not going to be broken up or anything. So I can just keep them nice and whole. All right. That is it for addition. In the interest of saving time, I'm going to skip the other one that we missed, the number 4. Nothing changes. Just draw them. They have a whole rectangle coming from each one. But so what? I just merge them and get 2 whole rectangles. And then see from the portions that are left that I'm merging, can I get another whole rectangle? And then update that accordingly.
Please remember to click the like button if you enjoyed the video, and to subscribe if you want to be notified of more videos. Thank you.